Section 4.10, the tension force. This is the last of our individual forces to take a look at. And it involves anytime you have a cable or a rope that is able to then transmit a force. This is known as the tension force. So a string, a wire, a rope pulls on an object, right? Note that the tension force is always going to be a pulling force, right? You can't push an object by a rope, right? If you have something, you can't just sort of like try and push an object. You always have to be pulling with a rope involved. And so the direction of the tension force, the direction of this, is always going to be in the direction that the rope is pulling. So the hand is pulling on the rope is pulling on the block with this tension force T. And it turns out that it will be equal in length, equal and opposite in how it pulls, right? So it's there's this pulling force to the right, but there will be an equal and opposite reaction to that with a negative tension there. Now, we're going to assume here that we have massless ropes, so that will transmit the tension undiminished from one end to the other. This is a very powerful thing. That means if you pull down on a rope and it has this pulley, it's a massless frictionless pulley, then the tension that you have will transmit to the other end and will work on the block with the same magnitude. And so if you pull down, the tension will actually be up on the block with the same magnitude of as you pulled down. You don't have to worry about losing some of that force in it. And it again is just in whatever direction that the rope is going. So pulleys can change the direction of the tension force, but it will always be pulling on the object of interest. So hopefully this helps to briefly introduce it. The tension force isn't something we have an equation for. It will always depend on the other parameters in the problem. So it will depend on how much mass there is in this block, on if there's acceleration in the block, if there are any other forces that are acting in the same vertical direction as the block, in the same direction as the tension force, or opposing it. So we'll see that that's something, the tension force is one we'll always have to solve for. We'll get more to that in the next section. First, I wanted to briefly summarize all of our contact forces here. So the contact forces that we've seen are the normal force was our first one. It's always perpendicular to the surface. Then we had the frictional force that's parallel to the surface. These both come from contact between the object and the surface. Within the frictional force, we saw static, which has a direction that opposes the force acting on an object. It opposes the direction of attempted motion, but static friction occurs when there is no motion. Then we have kinetic friction, which is just applied in a direction opposite the velocity. So if the block is going down, the force of kinetic friction is up. Finally, the tension force is when you have a rope or a string that pulls on an object and the direction is always in the direction of the rope. So it will always be a pulling force. So added in here the weight of the object, because that's one that, even though that's not a contact force, that's one of our non-contact action at distance forces. That's the main other force that we'll see when we have objects that we really need to make sure to include and draw in. And this also depicts that the weight is straight down. So it's not necessarily in the y direction if we have rotated our axes, which we will do in many cases. So that sums up all of the different forces we'll see. In the next two sections, we'll look at how we can apply each of these forces along with Newton's laws in order to solve some problems.